Hello everyone and welcome to today's mini lecture. Today we are going to look at how we use our stoichiometry roadmap to solve for acid-base neutralization problems. So as you can see in front of me, I have the stoichiometry roadmap that we used in general chemistry with one addition. Now we are going to use one more where we start with concentration. So if you remember, we have concentration, which is measured in molarity, capital M, and capital M is the number of moles over liters. So if we can factor out the liters right here, that would leave us with just moles. So it doesn't matter how you get just to moles, but once you get to moles, if you have a balanced equation, you can then do a mole-mole ratio. And then from your mole-mole ratio, you can now go back down and find the concentration. So all you have to do is know what the final volume is going to be, and you'll be able to determine the concentration of it. So let me work an example problem for you. So we are going to look in our notes, and in our notes, you can see example problem number 1. It says we have 27.4 milliliters of 0.15 molar HCl, and it reacts with 30 milliliters of the KOH. It says, what is the unknown, that'll be the KOH, concentration? So I would first need to go ahead and do a balanced equation. So I have HCl, and it's going to be added to a KOH. And if you remember, all acid-base reactions are going to give me water, which is H2O, and it's going to give me a salt. The salt is made from the metal of the base and the non-metal of the acid. So in this one, it's going to be a KCl. And both of those is a positive 1 and a negative 1 oxidation number. So even though I didn't write the crisscross, I did the crisscross up here. So I look at it, it's all 1. Then there's 2 over here. Actually, there's 2 hydrogens, 1 chlorine, 1 potassium, and 1 oxygen. So it's actually balanced. So I'm going to go back in and start with my concentration. So I'm going to put the concentration of the acid, which is 0.154 moles per liter. And that's what I'm starting with. Now, the reason I chose to start with this one is because that's the one that I knew both the volume of it and the concentration. So this is going to be considered my stock solution. So now I need to get this liter to factor out. So I don't know the actual number of liters, but I do know milliliters. So all I have to do is divide by 1,000. So I'm going to say 0.0274 liters. Guys, when I do that, I have just factored out my liters, and I'm left with a mole. So just like in all of our stoichiometry problems, I do a mole-to-mole ratio, and the mole-to-mole ratio is always what I'm looking for on the top, which is the KOH, what I'm factoring out on the bottom, which is the HCl. At this time, it is a 1-to-1. It is a 1-to-1 mole-to-mole ratio. So the moles of the HCl are now factored out. So I am left with moles of KOH. They didn't ask me for how many moles, they asked me for the concentration. So now all I have to do is put my liter of the KOH on the bottom, and that will tell me the concentration. So I come back over here and I have 30 milliliters, that's 0.03 liters. So guys, I'm going to go in and just put all of this in here. So I have 0.15, try it one more time, let me clear it, 0.154 times 0.0274. That is going to be equal, and it's a 1-to-1 ratio, divided by 0.03. So it's 0.03. My final answer is going to be a concentration of 0.141 molar of KOH. And I just followed my I just followed straight up the mole map. I went from concentration to moles, mole to mole ratio, moles back to concentration. So now what I would like to do is work one more problem for you. And the reason I choose this problem is because it is a problem that does not have a 1-to-1 ratio. So I'm going to do problem 4, and then I'll let you finish up the rest of the front and the next pages. So it says that I have 18.5 milliliters of 0.05 molar H2SO4. So there's my acid, and it reacts with 21.0 milliliters of BaOH2. And there is my base. So I'm going to add these two together in a balanced equation, H2SO4 plus BaOH2 yields, and you always get, doesn't matter, you always get a water, H2O, and you're always going to get a salt that is going to be composed of a Ba and, in this case, an SO4. Now again, guys, I want you to see, I wrote BaSO4 and I didn't show you the crisscross, but I know that barium is on the periodic table in the second column, so it's a +2. SO4 is a -2, so it canceled out, and I just put BaSO4. All right, so let's go ahead and start with the molarity, which is 0.05 moles per liter, and that is going to be of my H2SO4. So what I need to do next is to get rid of that liter right there. And if I do that, that is going to now take me to moles. So how much am I given? 0.0185 liters. And always remember, if you're given milliliters, you do have to change it over to liters. So now I'm going to do a mole to mole ratio. I am now looking for the concentration of my barium hydroxide. I'm factoring out the H2SO4 because that's what I started with. Now when I come up to my balanced equation, hey, haven't balanced it yet, so I need to go through and balance it. So let's go through and look at this. I have 4 hydrogens, 2 oxygens, so I'm going to have to put a 2 right there. When I put that 2 right there, that gives me 4 waters. Let me make sure. It gives me 4 hydrogens. Yes, it gives me 2 oxygens, a barium, and a sulfur. All right, so when I go through, actually this one is at a 1-to-1 ratio because there's a 1 right there and a 1 right there. But if I had balanced it and it had been a 2 over here and a 1 over here, or vice versa, then I would have put a 2-to-1 ratio. But this one works out as a 1-to-1 ratio again. When I do that, my moles of the acid factor out. Now I have moles of my barium hydroxide. But they didn't ask me for moles, so I'm going to have to put the moles over the liters of the barium hydroxide. When I do that, I'm going to divide that by 1,000, be 0.021 liters. And now I can go through and figure out my answer. So I'm going to say 0.05. And that's going to be times 0.0185. It's at a 1-to-1 ratio, and then I'm going to divide that by 0.021, and I get a final answer of 0.44, and that's going to be molar of BaOH2. All right, so guys, what were we supposed to learn from this one? You were supposed to learn how to follow your stoichiometry roadmap to do a neutralization reaction. Now, I know somebody remembers that when we did this in general chemistry, we used M1V1 is equal to M2V2. The only problem is that only works if you have a 1-to-1 ratio. Guys, I'm here to tell you that at the AP level, you won't get a 1-to-1 ratio if they asked you about one of these on your AP test. It'll be at a 1-to-2 or a 2-to-3 or some other type of ratio. So just make sure that as you're working them, you do your balanced equation and you put your mole-to-mole ratio right here accordingly. So I hope that this has helped you, and if you have any questions, by all means, just let me know.